All right, so how's everything going? Well, awesome. All right. So any issues with Linux access or with the one-day program so far? I saw lots of submissions for the ODP, but I haven't checked to see if everybody did it yet. All right, so hopefully everybody has at least tried it, and if you haven't succeeded in it, you have a plan for how to get it to work. And I set up a bunch of Unix accounts last night for everybody who emailed me, so everybody should be set with Unix access. If not, let me know as soon as possible. So I messed up yesterday. I failed to record this lecture, so that one's not going to be on YouTube, but the first morning section was recorded, so that's up on YouTube. And I'm recording this one, and I recorded the previous one today. So there's a link on Canvas to the lecture videos, and that takes you to a YouTube channel. I'll keep uploading these. A lot of today is going to be spent with you working in groups at the board, doing some problems. So that won't be a very exciting video to watch, but the initial stuff will be in there. So let's see. So I want to pick up where we left off yesterday and just talk about the service learning project in some detail, because that's your first real sort of serious deliverable coming up on the 10th. So if you go into 224, let me take this down. Come down to service learning projects. So there's a proposal upload which is due October 10th. Okay, this is the document you need to prepare and upload to Canvas by that date. So let's talk about the service learning project in some detail. And I don't think I got far through this yesterday. Was I just starting to talk about it? Okay. Okay. So so part of the education here at Clark is this 3-quarter long project you're going to work on throughout 224, 222, and 223. If you're an electrical engineering student, you work on this during 204, 252, 253, right? But every electrical engineering, computer science, computer engineering student works on this year-long project, basically, called the Service Learning Project, or SLP. And the idea of the SLP is to give you a chance to pick off an area that you're interested in knowing more about, but you don't necessarily learn about in the classes. So we talk about certain subjects in computer science, microprocessors, and so on, but maybe there's something that you want to go deeper in. Maybe you're really interested in artificial intelligence, and we don't really talk about AI in any of these courses here. WSU has courses in machine learning and so on, but we don't really get into that here. But maybe you really want to learn about it. And you know, Google has made available their AI tools, the back end to some of their machine learning systems. Maybe you want to learn more about networking and or something with microprocessors, or you want to learn how to make a game, or you've made a game but you want to make a better game. Something that you're curious about, hopefully passionate about, and that's going to take you beyond what you would normally be doing in your coursework. Okay, that's the scope of the service learning project. And it's a project you get to choose. It can be your own project. Whatever you think is going to be interesting to you and whatever you're going to feel passionate about is probably a good starting point. So, and this is basically what all this blurb says in text instead of speaking. So the goal is multiple in nature. One of the goals is to give you something so that when you leave Clark, you can go to an employer, an admissions officer, someone you're applying for an internship for, wherever, and say, here's this thing that I did when I was at Clark, right? Yeah, I went to my classes, yeah, I got good grades, yeah, I've got good letters of recommendation from people, but I taught myself how to do this, right? Or I was interested in that, and so I took some online courses and I did some experimenting, and I eventually came up with this amazing thing over here, right? And here's a link to it. and you can go look at what I wrote. It can be hardware, it can be software, it can be a mix. You can work in small groups up to 3 people. You could work with somebody who's an electrical engineer. You could work with someone who's doing aerospace, right? They're building a rocket and they need a control system, and you're going to design the control system using a Raspberry Pi, right? It can be pretty much anything that you think of. So it's nice to be told you can work on anything you want, but that's kind of hard because you have to actually be able to pin it down to something specific. And that's really the goal of the first quarter of the SLP, is coming up with a project and figuring out what it's going to entail to do that project. What's a reasonable timeline? What are reasonable expectations? How are you going to know if you're on track, and so on and so forth. So it's a lot of research and a lot of thinking and talking to other people and brainstorming to come up with a good project. And the first deliverable for the SLP is October 10th, and it's going to be a report that basically proposes what it is that you want to do. And this is not set in stone. This is a starting point, okay? Almost always, students end up working on something at least slightly different from their original proposal, okay? But you got to have a starting point. You got to have a first step. So this is a first step. And you take that step and you start exploring your idea, and you'll probably modify it. You might extend it, you might shrink it down. You might say, this is boring. I thought this would be really cool, but it's not. I want to do something totally different, right? So it's an exploration. And that's the other benefit of the SLP, is developing these so-called soft skills. Being able to come up with target dates, right? Milestones, things to gauge your progress. Being able to know what's a reasonable thing to take on, without taking on too much or something that's too simple, right? So being able to manage your time, being able to find motivation when you've got other things going on, but this is coming up to a deadline and you've got to push through a part that's not very interesting. All of these skills are like really, really important for success in school and for success outside of school. So this is a really cool thing that Clark does, in my opinion. When I was an undergrad, right, I spent all my time like working on projects of my own, but I didn't get credit for them, right? I had to do them in between the homework and going to class and all this kind of stuff. Here, you actually get credit for this, right? It's a required part of the next 3 CS courses. And the Tuesday of the last week of each quarter, we have an expo that takes place in that digital lounge over there. And basically, we break out a bunch of tables and you summarize your work into a single-page poster. And we print those for you, and you put the posters on the table, and people come from all over the school, and they walk around, they look at what you're doing, and they'll talk to you about it and ask questions and things like that. And that's another really valuable skill. It's basically a poster session, which as you start doing work in industry or sometimes, in a university, you start wanting to publish some of the stuff you're doing. And typically your publications start off in the form of a poster session. So you would go to a conference and you'd make a poster and you'd put it on a table or on a wall, and people would come around and talk to you about it. So it's a pretty cool opportunity if you take advantage of it. So let me show you what I would like you to turn in on October 10th, by October 10th. This gets submitted through Canvas. And I don't want you to turn in this piece of paper, okay? Sometimes I get someone and they hand me this piece of paper and they've penciled in a few words in between each of these things. That's not what I'm looking for, okay? This is just an outline, okay? This is a list of the type of information that I would like you to include at a minimum in your proposal. But your proposal is a full-on document, okay? I'm not going to grade you for grammar and sentence structure and things like that, okay? I'm interested in the content more than the style. But I want you to go into this with the mindset of, I've got this really cool idea. I want to get $1 million for it. So I'm going to go to this venture capitalist who has $1 million in their pocket, and I'm going to hand them this proposal. And they're going to read it, and hopefully they're going to give me $1 million to do this. Okay? Sometimes that happens. It's not going to happen in this class with me. I don't have $1 million. But go into that with that mindset. Okay? So you're selling this project and you're selling yourself. Okay, so what kind of information do I want in here? Definitely your name, okay? Full name. Always use your full name in school from here on out, okay? When you're turning in an assignment, when you're putting your name on a test or a proposal or a lab or anything else, always use your full name, first name, last name, okay? Because lots of people have the same first name, lots of people have the same last name too. So it's a good habit. Class CSE 224, date, whatever date you're doing this on. Project name, you don't have to come up with a fancy name, right? Nobody would ever let me come up with a name for a project because I'm horrible at it. I come up with descriptive names, and marketing-wise, terrible. But if you have a fancy name in mind or just something that you refer to your project by, right, go ahead and put it there because you can refer to it in the description. Or it can just be, you know, first-person shooter or something. So partners, I'll let you work in groups of up to 3 people. Okay, but if you're working with other people, make sure that your project can be split into pieces so that each person can be contributing more or less equally to the project. Okay, it's nice if you have a friend and they're kind of stuck and can't think of anything to do and they come up to you and say, hey, can I join your group? Yeah, it's nice to sort of let your friend do that, but make sure that they're going to take, you know, a half or a third of the project and basically contribute that piece of it. Now, everybody's going to turn in one of these documents, okay, and you should write it yourself. It may look a lot like what your partners turn in, but I want to see each person's view of what the project is, even if you're working with somebody else. So list all of your partners up there. And then project description, just in your own words. Tell me what it is that your idea is. Tell me what it is you want to do. It can be very technically detailed. It can be very down to earth. Whatever is going to convey to me what your idea is. And we're not sending you to the wolves with this, right? You can come to me and you can bounce off ideas. You can send me drafts of this and I can give you feedback and so on, okay? You don't have to just sort of do this in a vacuum and then turn it in and hope that you did the right thing. We can iterate on this, okay? Because in some sense, this is the most important part of the three-quarter process, is the proposal for what you're going to do, right? Which, as I said, is probably going to get modified over time, but we can work on this and talk about it and iterate. So, description of the project that you want to do. Okay, this is a learning project. The goal is not to do something that you already know how to do. You've been building PCs since you were 8 years old, so you're going to make a new gaming PC. Okay, well that's cool, but is it really a learning opportunity? Is it really going to take you 3 quarters to do that, and are you going to learn something outside of your courses? Probably not if that's something you've been doing. So try to do something that's going to stretch your capabilities, right? So if that's what you're doing, right, what are the most challenging pieces of that? What do you expect to learn out of this? So talk about that. Description of service component. This is a bit of a sales pitch, right? You're doing this because it's going to make things better for someone somewhere. And that's true of pretty much everything. Right? If you're making a video game, it's going to give students an opportunity to chill down after they've been doing a bunch of homework, et cetera, right? So you can always find a reason why this is a service project. Typically, people are starting from scratch in this first quarter, but it's possible that you've got a project you've already been doing some work on that you'd like to turn into an SLP. If that's the case, tell me what you've done on it so far and what the current status of the project is. And when you do this in winter, right, if you're continuing the project from fall, you'll have past progress to talk about for those next 2 items. Okay, the next section is milestones, and this is really, really important. So a milestone is, well, literally it's a stone sticking out of the ground that tells you how many miles you've traveled, right? Basically the same idea here. You're starting here. At the end of June, you want to be here. Okay, it's winter quarter, and you're right here. Is that good? I don't know, right? How long did it take to get from there to here? How long will it take to get from here to there? Who knows, right? You can say, well, I'm making progress, but I didn't do a lot, so I want to do more in spring, right? Well, that usually leads to a horrifying realization as June starts rolling around of like, oh my gosh, I really don't have enough time to finish this thing. Or I probably should have started this thing by now. So milestones are a way for you to gauge your progress throughout the next 40-some weeks. They're very specific goals that are measurable, okay? So a not so great milestone would be by the end of week 5, I want to have made good progress on my project. Well, what does that mean? When the end of week 5 comes around, how are you going to look at where you are and say, have I made good progress? Okay, a better milestone would be by the end of week 5, I'd like to have an outline of the 5 steps that I'm going to apply to this problem. Or I'd like to have done some research and picked out a particular VR headset that I'm going to work with, and I want to have ordered it, right? Things that you can say, yes, I've met that milestone, or no, I'm behind schedule, or yes, I met it, but I was 2 weeks ahead of schedule. Does that make sense? So there are ways to track your progress so that when you get to the end of June, worst case, you thought you were on schedule 3 weeks ago, and your schedule slipped. Well, maybe you're a week behind schedule. That's not a big deal, right? But if you don't have any of these milestones, you might get to the end and say, oh, wow, I didn't realize it's going to take me another year to do. Okay, so I would like you to specify at least one specific milestone for the halfway part of this quarter. So say the end of week 5 or 6. What do you want to have done by then? And try to think of something that you can actually check a box and say, yes, I've done this, or no, I haven't. At least 2 specific milestones for the end of fall quarter. So this is for the presentation at the end of, so it would be the Tuesday of week 10, or week 11. What do you want to have done by then? And then think about 2 general milestones for future terms. So maybe, middle of spring and middle of fall, winter would be 2 milestones. But give some thought to that, right? That's a really important part of this, because it helps you track your progress and know if you're being realistic or if you need to make adjustments. Major challenges you anticipate and plans for addressing them, right? Hopefully there's going to be some challenges to this. It's not going to be something you can do in your sleep. What are those challenges? How are you going to meet them? So I'm going to need to learn to program in Python, and I've never done that. So I'm going to go to Khan Academy, and I'm going to take a course, and it's a 3-week course, so I'm going to do it between the end of fall and the start of winter quarter, right? So that's nice and specific and gives you something to work around. And then the last part's just kind of for my own information, but also to give you some practice sort of talking about this. Why did you choose this project? Why are you interested in it? How does it relate to things that you're interested in, things that you're doing, things that you're hoping to do? What do you want to learn from it? And how do you think this is going to help your education? All right, because it's part of your classwork here. It should be contributing something to the learning experience here at Clark. So what do you see as the benefits to you and to your education of doing this? So write this up as a nice formal document, right, and upload it to Canvas by the 10th. And you have to turn it into a PDF to upload, so just export from Word or whatever your favorite editor is. And like I say, you can upload this early and send me an email and say, hey, can you take a look at my submission? And I'll be happy to run by it and talk to you and give you some feedback and so on. Make sense? All right, so be thinking about that, and if any questions come up, definitely let me know. All right, so my goal for today and for a good part of the rest of the week is to talk about algorithms and to give you some practice in working with algorithms. And as I mentioned yesterday, it's my belief that to be successful in these courses, you need to know how to write algorithms, right? And that's more important than knowing how to write C code, because that's a mechanical process. We can learn that pretty easily. We can learn to write Java code pretty easily. But you got to learn how to break problems down into steps. So I'm going old school on you, and we're going to work with something called flowcharting. And I think we usually touch on flowcharting in 120, and I mention it when I teach 270, the microprocessor course. I don't know if Scott goes over it in 121 or not. To be honest, flowcharting is not used that much anymore. It was used a lot, say, in the 60s, when we were writing code in languages that forced us to do a lot of branching from one place to another. And the flow of your program, where the computer would be executing instructions, would get really confusing. And flowcharts were a tool to help sort that out. But I think they're also useful for working in thinking in terms of algorithms versus programs. So I want to give you an overview of what flowcharts are about, what the actual mechanics of making a flowchart are. And then we're mostly going to spend the rest of the class in groups on the board, and you're going to be writing flowcharts for different algorithms. And then I'll leave you with a homework question to work on to turn in tomorrow related to flowcharting. So let me do a quick synopsis of flowcharts. So we always start with an oval at the top, and it's usually labeled start. And it's saying this is where the program begins, because we're going to have lots of boxes and arrows and lines on here, so we start at the start, and it's usually at the top too. And flow usually goes from top to bottom unless there's an arrow pointing somewhere else. So this will come down through this line, and it may come to a rectangle. And a rectangle is where we list any kind of statement. Set x equal to 0. Set I equal to I plus 1. Right? Just some thing that's going to translate into a piece of code that says do something. Okay? And we could put multiple statements in a box, particularly if they kind of go together. If we're initializing a bunch of variables, set I equal to 0, set sum equal to 0, set count equal to 1, we can put those all in one block. Or we might have things that kind of serve different purposes, and we might put those in separate rectangles. All right, sometimes we want to read input from the user or generate output to the user, and so we use this parallelogram. I call this a trapezoid in the last section. Everybody started drawing like a rhombus, so I'll just call it a parallelogram. So this is input or output. So read something from the user or write something to the user. And eventually, we usually have some kind of condition that we want to test. So we draw a diamond, and we would list some condition. Is x bigger than 0? Is the sum equal to I? Something like that. And any condition has two possibilities, yes or no, or maybe true or false. And you've got three corners here. You can pick any two of them you want and label whichever one you want yes and whichever one you want no. It depends on how you want to draw this. But we draw lines and blocks coming off of here. For example, check some condition, and if the answer is no, then we're going to go ahead and do this statement. And maybe after we do that statement, we're going to do some other statement. And maybe after we do that, we're going to check some other condition. And maybe if the answer is yes, we'll go ahead and do something. And if the answer is no, we'll do something else. And maybe over here on this first condition, if the answer was yes, we did some statement. And then maybe we join this branch, and we go on and we do something else. And then maybe down here we're done, and so we put an oval and we say stop. And maybe this branch over here, if this condition was true, it actually goes back to, I don't know, maybe this spot right here. So you draw an arrow and you show where you want that to move to in this flowchart. So if this condition's true, it'll go up here, it'll do your input or output operation again, check this condition, and so on. And this doesn't always map very directly to something like C, right? Because C, we don't usually use the go-to statement, even though it's there. But if you did Engineering 270, when we were writing assembly language code, we have these things called branches and go-tos. And that's basically what this is here, right? This is like a branch of 0 or a branch of not 0, for example. So flowcharts work well for assembly language. But my goal here, again, is not to write C code. My goal is to break down problems into algorithms. And for writing an algorithm, flowcharts seem to work pretty well. So let's try and write a sample flowchart as a group, and then I'll have you break into small groups and work on the whiteboard. But our first goal is print the numbers 1 through 10. And I'm going to say you must use a loop. Because you could just print 1, print 2, print 3, and so on, and you're done. But that's not as interesting. So I want you to use a loop to print out the numbers 1, 2, 3, 4, 5, up through and including 10. So I'll start off. Here's my contribution to the effort. All right. So what should we do next?
Declare some variables.
Okay, declare some variables. So this is going to be a statement. So we'll do a rectangle. So what should we call our variables?
Make sure it's X and Y.
X and Y, okay. And what should we initialize them to?
0.
And this is not C code, right? So I can do things like X equals 0, comma, Y equals 0. You want it to be something that's meaningful to you, okay? Ultimately, we would take this flowchart and we translate it into C. But translation is different from writing a program. Writing a program includes figuring out all of this logic, right? Once you've got a flowchart that spells out that logic, then you just take each block and you translate it into something in C.
Next we could do a while loop.
So we could do a while loop if this was C, but all we've got is these building blocks: statements, input, output, and conditionals, and arrows.
Okay.
And that's part of the goal of this, is to break these things like while loops and for loops down into these smaller pieces.
Condition then, I guess.
Say again?
I've done a condition.
Okay.
Oh wait, you don't need Y. That's not right. You just need X.
Maybe you have a block that increases X by 1 and then have a diamond that says if it is equal to 10.
Okay, so let's increase X by 1. And then some kind of condition. So what's a good condition here?
X is less than 11. Or 10.
Well, should we do 11 or 10?
11.
So X is less than 11. And what if X is less than 11? What should we do?
Print out X and then
Just move back on the
Okay. So let's print F. We should have done a slanted line.
actually the print out should likely before that. The condition.
We'll come back to that. All right, so print X, and then what do we do?
And then go back to the print.
Okay, go back to the increment. And if X is not less than 11,
And print again.
then all we got to do is stop. Okay, so details, yes. What's the first number this is going to print as it's written?
1.
It's going to print 1, is that correct?
Yes.
Right. What's the last number it's going to print?
10.
It's going to print a 10, because if X is 10, it's less than 11, it'll come down here. X will get incremented to 11. X is not less than 11, it'll stop. So this looks perfectly fine like that. Is this the right place to branch back to? What happens if we branched back to here instead? It's going to keep printing 1, because X is going to get reset to 0, incremented to 1, less than 11, it'll print 1. So it'll loop forever and it'll just print out 1 over and over. What if we branched back to here instead? It'll still just keep printing 1, because it won't be incrementing it, right? So, how many people here have taken Engineering 270? Right, so you got these branches, and you got increment, file, and skip of 0, and all this kind of stuff, right? And these kinds of things are really annoying to try to nail down in assembly language in particular. You can branch to just like one instruction too soon or too late, and code does something totally different, right? With something like this, since this is visual, it kind of jumps out at you more easily, usually, what the correct place is to branch to, what the correct type of condition is to check, and where you should be checking it, where should we be printing, right? What would happen if we printed right here instead of over here? Would that change anything in the output?
You'd end up printing 11 at the end.
You'd end up printing 11, because when x is 10, we'd come up here, increment it to 11, we'd print 11, and then we'd check to see if it was less than 11, say no, and we would stop. But could we change something if we really wanted to have our print statement here? We could change this to say if it's less than 10, right? So there's all these different ways that you can come up with an algorithm to do the same thing, but they're fundamentally different algorithms. I mean, they're the same behavior, but they look totally different from each other. And that's really important to understand, because you write a program a certain way and you look at a friend's program and their program looks very different. And sometimes when that happens, what do? We change our program to try to make it look like what our friend was doing, because their program works, so they must have the right program. Well, no, you might have the right program too, right? There's lots of ways to code the same thing. And my mantra in 224 is the way that makes sense to you is the right way, right? I don't care if you print here and compare to 10, or you print here and compare to 11, or you print before you increment and you initialize to 1. Lots of different options, right? Find the one that makes sense to you and let that be the way that you're coding. Let that be the way that you're putting down algorithms. Because if you try to force yourself to think in some other style, to me, that hinders the creative flow, right? And this is a creative process, right? This is pure creativity here. Nothing to do with C syntax or GCC or Linux or anything else. This is looking at a problem and finding different ways to think about it. All right, so I think you've got the idea. How many people we got in here? We've got a bunch of people. So I think we can do groups of 4 or 5 people. We can probably fit at least 6, possibly 7 groups on the board. So meet a neighbor or find a friend and split yourself into groups. Grab a spot on a whiteboard and a marker, and let's write some flowcharts.
That's the one.
See who I am?
No, it's fine. Just park right here.
I was thinking I was going to text you to see if you just park right behind.
So you want to add the numbers from 1 through 10 and then print out the sum. And you must use a loop. And I'm going to stop recording at this point.